understanding what the liabilities are associated with permitting those things. Lack of training and guidance, and they do need that. They don't have that. We're constantly, as a utility, finding ourselves doing a lot of education, especially in towns, because they actually end up calling us. Lack of resources to support aggressive deployment. This is going to be an issue with the utilities as well. You know, in the ZREC program, as we start to get more and more, you know, applications and aggressive rollout of solar, the utilities may not have the resources to process interconnection requests, and that could actually hold things up. You know, unfortunately, we have to ask for resources to be approved through PURA. We have to get approval before we actually get them, so it's usually too late by the time we get it. Process confusion, who goes first? You know, some of our solar developers in Connecticut, especially in our area, do I ask for a witness test on the system before I go to the town for them to release it, or is it the other way around? So that causes delay and all of those kinds of, you know, experiences that we've had. I talked a little bit about this. We have 3,000 connected. I do manage our distributed generation program at UI, and largely it's been combined heat and power type of large installation facility with small solar. Net meterings existed in Connecticut for a long time. It's a kilowatt hour net metering. It's not price-based. It's really just a credit on kilowatt hours as it's exported to the grid. LREC, ZREC, this is really the first. It's a brand new program. It's a 5 to 6 year solicitation program where utilities are required to contract for RECs for 15 years. First time that's happened in Connecticut, and the goal is to increase deployment. CEFIA grant programs will still exist, at least for the short term. And really there's two options for the industry in Connecticut. It's a ZREC contract plus net metering plus customer PPAs. That's one option. The second one is CEFIA grants, net metering, customer PPAs, and open market rents, if you're familiar with that. I think that's all I have.
My name is Guy Sliker, and I have no slides. We can probably all take our seats while I'm talking if we want, since I have no slides. That's in deference to our CEO, Gil Quinones. He'll be speaking here tomorrow. He'll provide a better overview of the New York Power Authority. In short, we're the nation's largest utility company, the nation's largest state-owned utility company. We operate about 1,700 miles of transmission circuits in New York State and generate approximately 20% of the state's electricity load. We don't own any distribution, so I'm not sure why I'm on this panel. We don't do any interconnection applications except for some very large ones with the with the large wind power plants. We have an energy services program. We spend about $200 million every year installing light bulbs, motor controls, HVAC equipment around the state, mostly for public entities around the state. As part of that, I run a group called Clean Energy Technologies, where we look to advance new clean energy technologies that might fit into our energy services program. We also look at energy technologies that might provide solutions to other stakeholders around the state. We've installed a little over 100 PV systems statewide, dating back to the early 1990s, when we installed some of the state's largest and first systems out there, and some of those are still in operation today. Those average about 100 kilowatts each. Generally, we have been implementing solar as part of an energy services package for our customers, and we always stress to our customers that we'd like to do a complete energy efficiency overhaul of their facilities prior to installing PV, and we are able in those cases to blend the economics of PV in with the economics of changing out their light bulbs to make it a little bit more attractive. We are currently participating in the Governor's New York Sun Initiative through a variety of new initiatives. We're partnering with NYSERDA on some large-scale collaborations to address balance of system costs in New York State. Thank you.
Finishing up real quick and then we'll take our seats. Hi, I'm Karen Forston. I'm with the Electric Power Research Institute. For those of you who are not familiar with EPRI, we are a nonprofit R&D organization really for the advancement of electro technologies. We're an accelerator between working with the Department of Energy and our national labs, all the way over towards commercializers. And we work with many of the electric utility companies in the country as well as abroad. And essentially, we've got a tremendous challenge. We talked a lot about cost, we talked a lot about benefits and value, and in fact, we are blessed, but also cursed, with one of the best interconnected electrical grids in the world. Very, very high reliability. And we want to ensure that we've got safe, reliable, affordable operations, but also sustainable. And so what I'm going to share with you just for a few minutes is 3 things that electric utilities, partnering with DOE and SunShot, entities like NYSERDA, California Energy Commission, as well as utilities around not only this country but abroad, are doing in the way of trying to see if our grid can handle increased penetrations of all renewables, but in particular distributed photovoltaics. We're going to talk about hosting capacities. One size does not fit all. I know we like to think about it in simple terms, but the electric system is very complex. Margaret already talked about we're going from a one-way power flow to a whole brand new system in transforming our grid. So it's very two-way, and we have to think about that because safety is paramount. We can't violate that for other drivers, if you will. Smart grid ready inverters. We believe that is a huge game changer. We'll talk a little bit about that. And then new screening tools. What can we do to expedite those requests that are in the queue? So background. EPRI is working with many utilities. There's lots of data out there. We're monitoring lots of systems so that we can pull in that data, better understand the performance, the variability of photovoltaics, because it is a variable resource. It's not always there, always on. We're also then taking that data and importing it into electric systems and models to better understand what is the capacity between one feeder versus another, versus this state versus that state. And it will give us ability to better target maybe higher penetrations of distributed renewables in certain targeted areas that are more cost effective so we can drive down those balance of system costs. In addition, one other element is to connect DC power, i.e. photovoltaics, to an electric grid. You need power electronics. One of the benefits that we think is to try to take advantage of those power electronics through inverter technologies. And if we could enhance those inverters with some new functional requirements to prop up the grid to provide both real and reactive VAR support, we can improve the quality, the reliability, and the overall grid support. So for instance, here we've got a system. Do I have a, I don't know if I've got it. We've got a feeder on the right side, don't worry about it, it's a one line. Here's our voltage without photovoltaics. Here's our voltage now on that same feeder with some penetration, in this case 20% of photovoltaics. And you'll see actually the voltage goes up a good bit in a certain area. It's a little bit more jagged than the voltage without photovoltaics. But if you now then take those inverters and adopt some grid-ready functionalities, you can take that and actually cause some smoothing and improve quality and reliability with photovoltaics, with these smart grid-ready inverters. So through the SunShot Initiative, we're working with companies like National Grid. He just talked about the storage and PV system at Everett, Massachusetts. We're going to be deploying this because essentially we need to not only characterize the feeders, but to also demonstrate some of these new technologies to see how well they work. Can we learn best practices from each other and share them not only nationally, but internationally, where they have increased penetrations of renewables way far ahead of the United States, Spain, for instance, and other general regions. So inverters with smart grid functionality, we believe without any major changes to electric distribution systems, which we have to rely on to connect PV to today, We think we can double the PV capacity through these smart grid inverters. Last, we hope that all of these types of demonstrations, the modeling, the performance, will feed into our ability to develop short or easier or more simplified screening approaches so that we'll be able to get requests in the queue, screen them, and potentially come out with faster approvals and recommendations. Just to give you an idea, not one size fits all. Just if you'll look to the right here, you've got two feeders, and based on certain characteristics, voltage level, the size, the peak demand, peak load, etc., you would think most of them could handle about the same amount of PV. In this case, they're radically different as far as the amount of hosting capacity of that photovoltaics. So in a situation like this, if we tried to do what was on the left